What are real numbers? Well, real numbers are denoted by this kind of fancy letter R, and if you look it up, the actual official definition is that they form the unique Archimedean complete totally ordered field up to an isomorphism, which is a great definition, if you're a genius, which I'm not. So, a better definition for a real number would simply be any number that you can find on a number line, which makes it sound a lot simpler, because it is. So, you might be asking yourself, if there's such a thing as real numbers, what's the opposite of that? Is there such a thing as a fake number? Well, no, there's something called imaginary numbers, and they're denoted by this kind of fancy letter I. And before you ask, they're not numbers that come from, say, like your
imagination.
No. Imaginary numbers are numbers like the square root of -4. Now you might be asking yourself, isn't the square root of -4 just -2? Well, it's not, because we know that for that would have to mean that -2 times -2 equals -4, and that's not true. Because according to the laws of integers, we know that -2 times -2 equals +4. And there's nothing we can do to multiply two of the same numbers together to get -4. So we just say that it's Shut up, Spongebob. To better understand real numbers, it's easier to understand the entire system of real numbers and where different numbers fit into, we'll call them families. Now, I've devised this little lesson that I call the house of real, and I call it that because it looks like a house. So in this house of real, we'll denote it with the symbol for real numbers, there's rooms that don't quite look the same as what they would in any other family. For example, the very innermost room of the house of real includes what we call natural numbers. Natural numbers are all the numbers that you naturally learn how to count with when you're very small. 1, 2, 3, 4, 5, all the way up to infinity. Now, the natural numbers are what we like to refer to as like the baby numbers. They have the least amount of responsibility inside. When you get a little bit older in the house of real, you move to the next room, which kind of ends up looking like a bullseye. These are the whole numbers. Whole numbers are exactly the same as natural numbers, except they include 0. If you need a way to remember that, the word whole has a 0 right in the middle of it. Now, as you move on, as you figured it out probably, the next one looks like a bullseye as well, and those are all of our integers. The integers are all of the whole numbers and their opposites. So while we have 1, 2, 3, and 4, we also have -1, -2, -3, and -4. 0 is still included in there as well, it just doesn't have an opposite. And the last room inside the house of real are all the rational numbers. The definition of a rational number is any number that can be turned into a fraction. Now, that includes things like repeating decimals, like 0.33333, because we know that ends up being 1/3, and also terminating decimals, which means that it just ends, like 0.25. That's just 1/4. So any sort of fraction is rational. If you need a way to remember this, the word rational has the word ratio in it. So if you have to say ratio no, then whatever, as long as you remember that if it's a fraction, it's rational. Now, that begs the question, if there's rational numbers, is there such a thing as not rational numbers? There are, and they are called irrational numbers. And they're what we refer to as like the teenagers of this family. And where better to keep the teenagers of the family? But the garage. So irrational numbers are, you guessed it, any number that can't be turned into a fraction. And your most famous irrational number is definitely the number pi, because it goes on forever and it has no discernible pattern that we know of. So basically, if you have a non-repeating, non-terminating decimal, like this one, then it's going to be an irrational number. If it goes on forever and you don't know what's going to come next, it's an irrational number. The last thing you need to know is that anything inside the bullseye belongs to each successive family on the outside. So an example what I'm talking about is all natural numbers are whole numbers, all whole numbers are integers, and all integers are rational numbers. So a natural number is also rational. Anything inside that house is rational. Not all integers are whole numbers though, because -5 isn't a whole number. So remember, when it comes to the real number system, anything that you can find on a number line is a real number.